You have a choice between getting paid $9,000 today, $11,000 in 10 years, or $1,000 per year distributed continuously throughout the next 10 years. Assume that all money will be placed in a bank account that pays 2% annual interest compounded continuously throughout the 10-year period. Find the present and future values of each payment option and state which form of payment is best and which is worst. Okay, let's go ahead and make a little chart here. We've got the option of getting paid some money today, and then we're going to write down the present value and the future value. Okay, so if you get paid $9,000 today, what's the present value of that money? Not a trick question. It's worth $9,000 because it is today. Future value is our PERT formula. So 9,000 e to the RT. So R is 0.02, 2%. And then T, how much time are we talking about? 10 years. 10 years into the future. And so we type that number into the calculator, that expression into the calculator, and we get around $10,992.62. So that's everything to know about that payment option. Or we could delay all payment until 10 years from now. And so how much do we get? Well, we get $11,000. So is that the future value or the present value? Well, that's the future value. 10 years from now, that $11,000 will be worth exactly $11,000 when it's handed to us. It's going to be worth $11,000. But we can walk that back into the present, that 10 years, that $11,000 in 10 years, what's it worth today? So here we're doing like a kind of a PERT formula, but it's the one with the negative exponent. So it's 11,000 e to the negative RT. And so that's a negative 0.02 times 10. And if you type that into the calculator, we get $9,006.04. So of the two options, we can see that the $11,000 in the future is worth just a tiny bit more. It's worth basically $6 more today, or around, like $7.38 more 10 years from now. Big buck. Okay, let's take a look at the last option. This is the calculus option. And so this is the one where the work is. So here's our continuous calculation. Ultimately, we're going to get two integrals here, but we're not just going to start with the integrals. We're going to build those integrals by slicing. So here's our standard income stream slice. You put a generic moment in time t. You squiggle that a little bit to the right and call it t plus delta t. At the start, time equals 0. At the end, in this case, is time equals 10. And then we're going to label this distance from here to here is t, and then the rest of it is 10 minus t. And this delta t space in here is much bigger than we're really imagining it, right? It should just be like fractions of seconds, whereas here it looks like it might be over a year's worth of the 10 years. Okay, so let's take a look at the money coming in on that tiny interval of time. The income is supposed to be $1,000 per year, but you're getting the money for not a full year, probably much less than a year. You're getting the money for delta t, which is probably some tiny fraction of a year. So for example, if delta t was half of a year, then you would get half of that money, half of the $1,000. You get $500 in half a year's time. So we just multiply 1,000 by delta t, and that's the amount of income coming in. And then we're going to move it, we're going to look at the present value and future value of that money. I like future value first. So the future value of the money just on that one slice is equal to, so it's still our PERT formula. I guess I can just write that PERT. But in this case, the principal is this red 1,000 delta t. And then e to the, all right, so R is still 0.02. But now t is not t. T is how long this money has to grow. So how long does the money get to grow until we look at the end of this experiment in the future? Well, it grows for 10 minus t years. So that's what goes up here. The amount of time left to grow. And so that's the future value of one slice. And so then if we wanted to, we could convert that to the future value of all slices. And we know that's going to become a summation, 1,000 delta t e to the 0.0210 minus, and then this t becomes a ti because we're going to count it, and we're going to let I go from 1 to n every time. And then what we should really do if we want the exact answer is let n go to infinity. Get those delta t's to be really tiny. And because we're in exactly the right form, we know this is going to become an integral. In this case, it's from t equals 0 to t equals 10. 1,000. I'm going to put the delta t becoming a dt at the end, and then we'll put the e part here. And then that ti just goes back to becoming a t. Okay, so integrating this is not too hard. I'll just give you one hint and say that you can use a u substitution to integrate this thing. I'm not going to do the integral, the antiderivative calculation here, but I'll just tell you the answer is $11,070.14. But there is work to do if you're trying to do that integral by hand. Okay, so we can put that up here, 11,070.14. Okay, so all that's left is the present value. So again, we're looking at the money coming in on this red interval. So present value is like the PE to the negative RT, or maybe it's BE to the negative RT. Let's try it. So here we go. This is now the present value of one slice equal to, okay, so like I said, I think your book calls it BE to the negative RT, where B is the amount of money we're talking about, which is still the red, this red thing right here. The amount of income is 1,000 delta T. E to the negative, R is 0.02, but T is not T. T is how much time we're going backwards into the past. So if you are standing right here, because we're talking about this amount of money, so we're standing right here, and we ask ourselves how much time has elapsed, kind of walking backwards to the beginning of this experiment. It is T years. Did I say it wasn't T? I lied, it's T. So it's just that. Okay, and then just like before, we can do the present value of all the slices. Limit n goes to infinity. Summation I equals 1 to n. 1,000 delta t, e to the negative 0.02, and then that t becomes a ti. And then this becomes the integral, 0 to 10,000. We'll put the delta t as a dt at the end, e to the negative 0.02t. This integral, again, you can do by hand, again with the u substitution. I'm not going to show the details, but we should get $9,063.46. And so then the question says, which of these options is the best and which is the worst? So we can either look at the first column or the second column. So in the first column, you could have $9,000 today, or $9,006 today, or $9,063 today. So clearly this one here is the best, and the 9,000 today is the worst. Or we could have looked at the last column. So 10 years from now, you could either get $10,992, or $11,000, or $11,070. And again, the bottom one is the best one, and the top one is the worst one. So it doesn't matter. You didn't need both columns to answer best or worst.